What's up, everyone? Today we're going to look at a super important machine learning coding problem that, even though it seems easy, many people actually get wrong. And if you encounter this in an interview or an exam, this could actually be quite devastating. So we're talking here about problem number 3, reshape a matrix. This is a super important operation that's used all the time in machine learning. And in this video, we're going to look at 3 ways to solve it. The first one is going to be super explicit. Second one's going to be more fancy. And the last solution is going to be much faster and compact. So if you're new to this channel, in this series, I show you how to solve essential machine learning coding problems. And we're going to use this website, deepml.com, which is a great website with lots of free resources and coding problems. And as someone with over 6 years of experience in machine learning, these stuff are really my bread and butter, and I really enjoy solving these riddles. So let's look at this problem, reshape a matrix. And here we need to write a Python function that reshapes a given matrix into a specified shape. And if it can't be reshaped into that, so we need to return an empty list. So let's look over here. The matrix is given as 1, 2, 3, 4, 5, 6, 7, 8. This is a matrix of size 2 by 4. And we need to reshape it into a matrix of size 4 by 2. And this is the output. Again, 1, 2, 3, 4, 5, 6, 7, 8. So right over here, this is what most people get wrong. Reshaping is not like transposing. So reshaping preserves actually the order of elements if you read them out kind of like this, like I did row by row. And transposing will actually mix up kind of the order of the elements. In the previous video, we saw how we rotate around diagonal, and this kind of mixes up all the values. So right over here, this is a very important insight to keep in mind. And if you want to learn more about this, they have this little button here to learn more about the topic, which is really nice. So now let's dive right into the code. So over here, they give us Numpy, and they want us to solve this in Numpy using this, and then afterwards return it using a toList method. We're not going to do that. We're actually going to do that in our third solution, but I want to show you something much cooler and more explicit in our first 2 solutions. So our matrix A is given as a list of lists, where each list inside, this is actually a row in the matrix, and the number of lists is the number of rows. And we need to reshape this into this new shape. So first of all, let's try to handle this edge case of when won't we be able to reshape the matrix. So let's look right into it. I'll close this over here. We can focus on the code. There we go, much better. Okay, so our matrix is going to have P rows and Q columns. I'm writing old over here because we're going to have a new shape, of course, that we're going to reshape into. So the number of rows, we said that's the number of lists, that's P old. And the number of columns, so we just need to look at the first entry over here to really get an estimate of how many columns the matrix has, and meaning the length of each row. And we need to try to reshape this into a new shape. So P new and Q new. And this is going to be the new shape we need to turn into. So here, let's stop and think, in what situations won't we be able to do this operation? Now, if you're thinking, oh, okay, we need to use these to see how many elements we have, you're exactly correct. The situations in which we can't do a reshape is a situation in which we try to change the number of elements, either add new elements or old elements, or delete elements, and this is just not allowed by the reshape operation. So let's check if the number of elements in the matrix will be preserved by this reshaping operation. So we're going to, since this is a rectangular matrix, we're going to count up the number of elements by multiplying the height and the width of the matrix. And if the new height and width, the total area is not the same, it means that we don't have the same number of elements. In this case, we need to return an empty list. So now that we got that out of the way, let's move on to actually doing the reshape operation. And here is another thing that many people forget. This is exactly where what we talked about people get wrong. The number of elements must be the order of elements must be preserved. So the way we're going to ensure this is by doing what's called an unrolling. So we're going to unroll this matrix, which is currently a list of lists, into one giant list. So everything is going to go into a single list. So we're going to iterate over the rows of the matrix A. And what we're going to do is we're going to extend the unrolled version of A. So this is just going to put everything in one giant list. There's actually another way to do this in Python. You can do this plus operation. So we can, this is the previous version of the list, and we can use plus and add the next row. And in Python, this actually does the same thing as this, but this is a much more explicit way of writing this. So let's leave it like that. And now on to our first solution. This is, now that we got the unrolling part, here we're going to do something that's a little bit tricky. So stay with me. Now we're going to fill out the new matrix element by element. Let's go. Reshaped matrix A. So here, we're going to initialize it all with zeros. And each row is going to be of length q new, meaning it's going to have q new columns. And how many rows is it going to have? It's going to have p new rows. So now this way of writing it, this is a way when you multiply a list by a number, it makes a list with the same value, but with that many number of elements. So this is going to be a list of zeros of size q new. And then when we go like this with the list comprehension, we're going to have a list of lists. We're going to have p new rows, where each row is going to be of size q new. Got that? Good. Now let's start filling it up. So we'll fill it up row by row, in the new rows, of course. Q new. And whoop, we're running out of space. And now let's fill up the index ij in our new matrix. And we're going to grab it from our unrolled matrix. But wait a minute. What should we put over here in the index? We unrolled everything. How do we keep track of everything? So let's see which index we really need. So let's think about this. So if we're moving on a new row, so the index in the new row is going to be j. But what about all the rows we already went over? So each row is going to have q new elements, and we went over I rows. So since I starts from 0, the first time we run this for loop, this is just going to be running over index j, which is cool. And the second time I is going to be equal to 1, and then again we're going to be going over the index j. And as you can see, this is just going to continue to grow until we reach the final index in unrolled. And as we know, if we made it so far, there's definitely the same number of elements. So we can be sure that this is exactly what we need, and we're going to get all the values we want. And let's just return this. So let's see if our code runs. Okay, now we got it. So I don't know what I did, but I just rewrote the line again, and now it worked. I guess there was some small syntax issue here, but that's it. That's for our first solution. And as you can see, this was our reshape operation. Now let's look at the second solution. So I told you this one is going to be much cooler, and you'll get extra points if you do this in an interview. It's much more elegant and shows a better grasp of Python. So let's do this in one line. Ready? We're going to do this row by row before we did this element by element. So let's take our unrolled matrix, and now we're going to grab, using slicing, we're going to grab different slices of this list. So we're going to grab slices for each row. So each row starts at index I times q new and ends at index I plus 1 times q new. So this means that it's definitely going to be of length q new. I is going to start from 0. And this way, we're going to grab from this unrolled matrix each row one at a time and put it in this list. Isn't that cool? And then with this list comprehension, this is exactly what we're going to get. We're going to get a new list of lists, where each list is of size q new. And we just need to return it. And let's see if the test passed this time. And they did. Very cool. So this was our second solution, which is much more elegant. Now, as you guessed, this third solution is also going to be the solution they really wanted us to solve, which is to use Numpy. So in Numpy, everything is much simpler. We just need to convert our matrix into an array. And now we just call the Numpy reshape operation. So we just do a.reshape with our new shape. That's it. Now, the only thing is, because they wanted us to return it as a list of lists, we need to use this toList method. And if you ever encounter this problem in an interview, what I would do is, this is definitely you need to do in both cases, this error handling, although the reshape would just throw an error if you try to do something funky with the shaping. I would mention this, like you can solve it in Numpy. Probably they'd want you to do one of the two solutions that I showed you at the beginning. So it would be nice to throw this out, but they're probably not going to want to ask you to just call the Numpy reshape function. So let's just verify that this works. We'll run the new tests. And yeah, looks like this runs. So we saw all the three solutions. The first one was element by element. The second one was row by row. And now is the final one, which is much faster and much more practical, which is using Numpy. So just so you don't get confused with transposing a matrix, remember reshaping is different from transposing. I'd recommend checking out this next video.